Hi, greetings to all. This is Sheikh Shabir. I'm working as a physics teacher from 17 years. I have a lot of experience in teaching physics in foundation classes, and not only for that, in physical science. In all these years, I am striving for the children to do well for all their well-being. Not only that, so many students are actually well settled in their lives also. So I can say proudly that my students are actually doing well in their life. Yeah, today let us see how universal law of gravitation, which is given by Newton, that I'll explain you. So universal law of gravitation, and after that acceleration due to gravity, and then the relation between acceleration due to gravity and universal law of gravitation that we can observe today. Okay, so let us see once what is the first universal law of gravitation. So before we are explaining this universal law of gravitation, first of all, how the gravitational force will be exist between the two bodies, let us observe. For example, if any two bodies we have with a definite mass like this, for example, these two bodies are having mass m1 and the mass m2. So these two are actually finding some distance between these two. Yes, we have some distance between these two, and then actually we are taking the distance from the center of them. Okay, and the distance, if you are observing, you can take it as r, or otherwise d also you can take. So then, as we know, these two have masses, so automatically they may have some attractional force between these two. So this particular attractional force is only known as gravitational force. And according to Sir Isaac Newton, whenever the two bodies are having masses, these two are actually separating with some distance r, or otherwise d you can take. Then the force of attraction between these two, so you can take that force as F, and this force of attraction between these two bodies will be directly proportional to product of their masses. So I can take here force F is directly proportional to product of their masses. So let us take it as equation number 1. Then if you are finding the distance between these two is r, so while the distance is increasing, so automatically the force of attraction will be reduces. Already we know that. Why? Because whenever the two bodies are having some distance and the distance is going to be increased, then automatically the force of attraction will be reduces. So like that, what we can take here, the force of attraction F is inversely proportional to square of distance between them. Let us take it as equation number 1 and 2. So let us find the relation between these two first now. So as the force is directly proportional to product of their masses and inversely proportional to square of distance between them, by taking these two equations from 1 and 2, we will get F. Force F is equal to, or otherwise directly you can take proportional to m1 by m2 r square, or otherwise as I said, that is d square also you can write. So like that, to remove this proportional symbol, always the force, it will be equated to the product of the mass and inversely proportional to square of distance between them. We will just multiply with a proportionality constant. So that proportionality constant, let me take it as here capital G, and capital G m1 m2 by r square we can write. So with this, what we can just find here, the force F is equal to capital G m1 m2 by r square. Where this capital G present for us, that is actually proportionality constant, and that same proportionality constant we can call it as universal gravitational constant. What is it also known as? Universal gravitational constant. So this universal gravitational constant that we can identify according to the masses of the two bodies, and in the same way the distance between them. So actually this capital G value is universally constant value, and it has its original value 6.67 into 10 power minus 11 Newton meter square per kg square. So this Newton meter square per kg square is nothing but unit of capital G. So remember this point here, children. Capital G is nothing but what? Universal gravitational constant. What is capital G? Universal gravitational constant. And this is always having a unit also, that is Newton meter square per kg square. And its numerical value is 6.67 into 10 power minus 11. So it is constant anywhere in the universe. So this point we need to remember. So according to Newton, what we can describe here, the force of attraction between any two bodies of definite mass is directly proportional to product of their masses and inversely proportional to square of distance between them. So this is the statement of universal gravitational law. And then we can derive a formula for it. Capital F is equal to capital G m1 m2 by r square. So hope you understand. And let us go from here. The most important topic you may know already in your previous classes, but exactly you are always having some confusion to describe it. What is that particular thing? Let me explain you. That is nothing but acceleration due to gravity. So let us see what is acceleration due to gravity now. So acceleration due to gravity I am explaining here. Let us observe what is it. Acceleration due to gravity we can describe with the letter small a. Acceleration we can describe with a, but we can describe with small g we can take. Acceleration due to gravity. Okay, let us see what is the acceleration due to gravity. As you know, let us observe. This is, you can consider as our earth. So from a particular height from the earth's surface, this object are already having some mass m. So as you know that whenever it is freely falling, remember it, what is happening here? It is freely falling. So whenever this body is freely falling, it always attracting to the center of the earth. As you know, our earth always pulls any object to the center of the earth. So while it is pulling towards the center of the earth and having mass m, so what is happening here, or what is actually present here, this is the large body which is our earth, and the small body which is small m you can take of having mass. Then this large mass is attracting this small mass. So what is present in between these two? Again we can arise here the Newton's universal law of gravitation. So that's why the same law we can describe here also. So what is going to happen here? It will be attracting towards it. So then the force what is applying on the mass towards its center, so this object is acquiring some acceleration due to gravity. Remember this point. An object which is having mass m is acquiring acceleration due to gravity. So due to gravity an object is acquiring acceleration. That's why it is known as acceleration due to gravity. What is it called? Acceleration due to gravity. And the force whatever it is applying, that is also known as weight of the body. And at this point whatever the force is present in between these two, we can take it as capital W also. And force formula as we know, force F is equal to m into A. But in the place of A we can write small g here. So the force is also known as, in this place, weight, and weight W is equal to m into g. So like that we can describe one point here. Mass is nothing but always constant anywhere in the universe, but come to weight of the body, that weight is always we can consider as gravitational weight, gravitational force. So gravitational force which is acting on the body is nothing but weight of the body. Remember it. So gravitational force which is acting on the body is nothing but weight of the body. So weight is also known as m into g. So this g has we got how? Just we can understand. Whenever an object is falling with mass m towards its center means towards the center of the earth, Then how it comes? Because of gravitational force. So due to gravitational force, this object got acceleration. That's why it is known as acceleration due to gravity. Okay. So with this particular point, wherever we observed, force is also known as weight, and weight is also known as what here? M into G. The same concept, just we are going to implement to get a relation between universal law of gravitation and in the same way acceleration due to gravity. Let us find the relation between small g and capital G. So let us see what is the relation between these two. So let us see the relation between small g and capital G. Let me tell you first what is small g here. This is nothing but acceleration due to gravity. Acceleration due to gravity. And what is capital G? This capital G is nothing but universal gravitational constant. Universal gravitational constant. Let us find the relation between these two. So to find the relation between these two, as I observed before also, the same diagram let me show you. This is an object of mass m, okay, and then if you are observing, this particular object where it is present on the earth surface, or otherwise simply you can take some gap also between these two. So then automatically we can identify here as we are getting. So let us see. So this is as center of the earth, we can take of mass m. So always from here to here, the distance you can take it as r, small r also you can take, no problem. The distance which is more than radius of the earth, no, that's why you can take little bit extra. So from here to here, the distance you can take it as r, and what is the mass of that body? Small m. And this is nothing but consideration as our earth, it contains large mass, you can take it as capital M. So according to first law, what we can find? According to universal gravitational law, what I explained it today, that is force F is equal to, already we know, capital G m1 m2 by r square. Now in the place of small m1, you can take it as bigger M, that is capital M, which is nothing but mass of our earth, and m2 is nothing but mass of the body, and distance between them is given as r square. So capital F is equal to capital G, capital M, small m by r square we got. As we know, whenever object is actually freely falling, then the same force will also be equal to what? Weight of the body. That's why force F is equal to mg now. So let us take these two as equation number 1 and equation number 2. So from these two we can get a relation. What is that? Let us observe. That is m into g. Both will be equal to capital G, capital M, small m by r square. So like that, if you observe, this is small m and small m, both sides will be cancelled out. As we know, the relation will be changed as like this, that is capital G is small g is equal to capital G m by r square, like this. So simply find the relation between these two in this way is very easy. You just see, small g is nothing but acceleration due to gravity, capital G universal gravitational constant, capital M is mass of our earth, and small r is nothing but the distance between this body to this body, or otherwise the same formula we can find, or we can just describe in another way. For example, if you want to find the acceleration due to gravity of any other planet, you can write capital G and mass of that planet by radius of that planet square. So this formula is very much useful to us to find the acceleration due to gravity of any other planet if you know the mass of that planet and radius of that planet, automatically we can find acceleration due to gravity of any planet also we can find here. So hope you understand all these topics what I have explained you today. Universal law of gravitation, next acceleration due to gravity, and the relation between small g and capital G, which is acceleration due to gravity and universal law of gravitation. Thank you.